Welcome to Chemi at KPS. In this session, we will demonstrate the complete procedure determining the calorific value using a bombcalorimeter for the pyrolysis oil that we extracted in our previous experiment. This is a complete bombcalorimeter setup used to determine the calorific value of fuels. Here you can see the complete bomb assembly along with all its internal parts. This is a stainless steel bomb vessel designed to withstand high pressure during combustion. Inside the bomb, we place the crucible, which holds our fuel sample during the experiment. These are the ignition electrodes where the fuse wire is attached. The fuse wire connects the two terminals and ensures proper ignition of the sample. Now we fix the crucible into position and make sure it sits firmly on the support ring. Next, we connect the fuse wire carefully so that it lightly touches the sample, ensuring smooth ignition. Once all parts are properly assembled, the bomb head is aligned with the vessel and tightened securely to create an airtight seal. This completes the bomb preparation before filling oxygen and starting the calorific value test. Asterisk. This is our pyrolysis oil sample, extracted in the previous experiment. Before loading it into the bomb, we first measure the weight of the empty crucible. This gives us the initial mass, which is needed for accurate calorific value calculation. Next, we carefully add 1 gram of the pyrolysis oil into the crucible. The exact weight of the oil sample is very important because the calorific value is calculated per gram of fuel. Once the sample is placed properly, the crucible is ready to be fixed inside the bomb for ignition. Asterisk. First, I cut a 6 centimeter fuse wire and insert it into the electrode slots of the bomb. I tighten the caps to hold it firmly. This fuse wire is used to ignite the sample. Sometimes 10 centimeters of cotton thread is added to help in the ignition process. About 1 to 2 milliliters of distilled water is added inside the bomb. This helps to create a saturated atmosphere and absorb acids formed during combustion. After preparing the sample, the crucible is placed carefully inside the bomb. The ignition wire is positioned so that it touches the sample properly, ensuring smooth combustion. Now, the bomb head is aligned with the vessel and tightly closed to create a completely airtight chamber. This sealed environment is essential for safe and complete combustion of the fuel sample during the calorific value test. Next, I connect the oxygen filling assembly to the bomb and ensure that all the joints are completely leak-proof. The oxygen valve is opened slowly and the pressure is increased gradually until it reaches around 26 kilograms per square centimeter. Once the required pressure is achieved, the valve is closed immediately. This high-purity oxygen ensures complete and efficient combustion of the fuel sample inside the bomb. The bomb is now lowered gently into the calorimeter vessel. After positioning it properly, distilled water is added into the outer jacket until the bomb is completely submerged. The exact amount of water added is carefully measured because this water absorbs the heat released during combustion. This rise in water temperature is what allows us to calculate the calorific value accurately. The principle of operation of the bombcalorimeter is quite simple. A carefully weighed sample is placed inside the stainless steel bomb. After sealing the bomb and filling it with oxygen, the sample is ignited electrically. During combustion, the fuel releases heat, which warms the surrounding water bath. A digital temperature sensor continuously records this rise in temperature. Using this temperature change, we calculate the total heat of combustion and determine the calorific value of the sample. Asterisk. Before measuring any unknown fuel sample, the calorimeter must be standardized using a standard pellet with a known calorific value. By burning this pellet, we determine the water equivalent, or W, which represents the effective heat capacity of the entire calorimeter system. This value is essential because it is later used in the final calorific value calculation. We also record the ambient temperature before starting the experiment, as it helps ensure accurate temperaturized measurements. After the combustion is complete, we note the maximum rise in temperature and use a formula along with the water equivalent to calculate the gross calorific value, or GCV, of the sample. This GCV value tells us how much energy is released when the fuel is completely burned. This is how a bombcalorimeter experiment is performed to determine the energy content or calorific value of fuels such as coal, biomass, or pyrolysis oil. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe to Chemi at KPS for more science and engineering experiments.